Okay, I'm back, and as promised, I know it's taken me a little while. This is a supplemental to the 4 to 20 analog output signal that we did for the Yaskawa drive from the IDEC FC6A PLC and the analog card. Um, I know I'm going to be kind of vague on some of this stuff, so if I leave some information out that somebody needs to know, just shoot me a message or whatever, and I'll do my best to answer. This is going to be kind of quick because I don't have an actual Yaskawa drive. Of course, this is out of my home shop, and I just don't have stuff like that here. But I'm going to go through the manual. This is Yaskawa drives, in my opinion, are one of the easier to program drives. I don't work for Yaskawa, but their tech support is really, really good when it comes to troubleshooting and setting up a drive. You can call them up, and those guys, the engineers, they're pretty handy people. They will help you out and get you going if you have some troubles on startup or with your tuning and anything like that, or your actual how you're going to use it. So just keep that in mind. Also, I want to note that I just got an email from IDEC. They're going to start doing free webinars, and I don't know who all has access to that. I would say if you probably go on IDEC's website and register with them, you're going to get the free webinars also. And it says also they're going to send you a link to them, so they're going to be recorded. So if you can't actually sit in on the live webinar with the Q&A, you'll still have access to the webinar as a video. So that's pretty cool. I mean, that's a pretty good deal, I think. I mean, it's probably going to be the same kind of format as their classes, it looks like, but in an hour at a time. I'm definitely going to check into it. So anyways, let's get into this. I'm just going to use the Yaskawa A1000, which is a pretty common drive. The A1000, the V1000s are really, really common. And a lot of drives program differently, but I mean, they all have good manuals. Yaskawa has real good manuals that goes through all the electrical installation and whatnot, the startup and programming. You just kind of follow down the list if you want to read the whole thing. But I mean, it's 544 pages, as you can see down here. But you can hit the high points and get a motor running. I mean, you're not going to run a drive that's pushing the space shuttle to outer space like that. I mean, there is a lot of engineering goes into some drives, but you get a basic drive, a conveyor going, or a something simple like that, or maybe some kind of drive that runs a line at a certain speed. I've never had trouble setting them up, put it that way, and I'm not an engineer. Anyhow, I'm just going to hit some of the high points on the connection. We went over the connection for the actual PLC coming out of the analog card. Okay, so I'm just going to I flagged some of these ahead of time to kind of show you what some of it is. All right, here's your basic wiring. Okay, you have to use this A2 terminal on this specific drive. Now, like I say, all drives are a little different. They're going to have a wiring layout and a diagram in them somewhere. You'll just have to flip through the pages and find it. So A2 is the one that you can use for a 0 to 20 milliamp or a 4 to 20 milliamp connection. Okay, down here, your AC, that is your common, right? So this is going to be your negative. This is going to be your positive from your output from your PLC analog output card. Okay, in doing this, there's a note right here, note 8. If you look down here to note 8, it says you have to set dip switch S1 to select between voltage or current input to terminal A2. We'll get to that in a second. I'll show you where that dip switch is. You have to have that set or it will not work. Depending on the PLC I set up for 4 to 20, those PLCs are capable of 0 to 10 or minus 10 to plus 10. So if you wanted to use a voltage input to this drive, that is entirely possible. Then you could use A1 if you wanted to, or A3. You're not confined to A2 as you would with the current input, which I just like the current input because I'm just more used to it. I've been told it's more stable. I don't know. I haven't used voltage input enough to say that is one way or another. It's just 4 to 20 is kind of like a pretty good industrial standard a lot of people use, and I know that's pretty much all I've ever used. Okay, anyway, that's your notes. You got to go to S2. Now we're going to go to signal selection. All right, terminal A2 signal selection. So in H3-09, you have to assign 0, 1, 2, 3. You got 4 different selections to select your signal. What type of signal are you going to use? If you're going to use 4 to 20, you have to input number 2. The default is 2. So if you get this drive, you buy it, right out of the box. It's never been used or programmed by anybody. It's going to automatically have terminal A2 set for 4 to 20 milliamp signal. Okay. Your dip switch right here, it's clearly marked V for voltage, I for current. Okay, we'll get to that dip switch here in a second. It maybe it's right down here. Let's see. Let me see if I got it on one of these where I've got the actual switch at. Yeah, here's your dip switch. Okay, S1. So see, it has V on one side, I on the other side. You want to make sure it has I. Okay, for 4 to 20. And it's telling you again up here, you got to go for analog 4 to 20. You're going to have to H309 has to be set to 2 for 4 to 20. H3-09 has to be set 3 for 0 to 20 milliamps. So make sure you have that set also. Okay, let's see what we're missing here. This is your tuning. You're going to have to do this. I'm just going to go through some of this. On any drive, you're going to have to go through there and check some of these parameters. Make sure they're set up the way you want. This is your modes of control, whether you're going to use voltage frequency control, setting 0, with speed feedback, open loop vector control, which that's pretty common, open loop vector control. You got closed loop vector control. That's where you have some kind of a feedback from an encoder from your motor so you can absolutely control speed. There's a bunch of different things you can go through. You could really educate yourself with one of these books if you want to go through it and read everything on it. Let's see, signal selection, we've already went through that. Parameter explanation, you have your motor parameters in E. Let's see if we can get on down to E. I'll show you what some of those are. That's where you're going to actually put in. A is usually where you put in your languages and all that stuff. On B, here's your analog terminals. B. Let's get on down there a little faster. Speed limits. Oh, there we go. Here we go on E. D. Reference. Say there's lots of settings you can go through. It does not hurt to go through all of them. Okay, now here's your parameters for your motor that you have to set in there. It's got an explanation. The input voltage setting determines the under voltage detection level as well as DC bus levels used by a KEB function and over voltage suppression function. You know, and it tells you VF pattern selection. And it's got the descriptions of each one of them. Predefined VF patterns. 50 hertz, 60 hertz, constant torque, 60 hertz is United States. You can go all the way down through here. It's got motor parameters. Anyways, it doesn't hurt you is what I'm getting at. Is go through there and read this whole manual once. I mean, if you're going to use this type of drive, and like I say, I prefer to stick with one brand of drive because they pretty much program similarly across the models. Or if you jump from this to an ABB and to a Danfoss or whatever, you're going to have a little bit of difference. And unfortunately in industry, when you have a lot of outside vendors building your equipment for you, you will wind up with several different brands of drives inside of an industry unless you are the one in control of all the specifications. And then you can dictate which types of drive you want so your guys or you can effectively troubleshoot them and program them. But anyways, that's pretty much all for this video. It's pretty short. If anybody has any questions on this, I will help them out. And like I say, Yaskawas I'm pretty good at. You started asking me questions about some of the Emersons and stuff like that, I'll have to look into it. I'm not as well versed in those. Anyway, that's that. That's pretty simple as far as your analog control of an A1000 drive. If anybody has a drive, maybe you can hook one up and play with it and get a little more in-depth on it. I do not unfortunately have one, but that's all for this one. I'm going to try to get some more videos out. So anybody has any ideas for videos or something I can handle, I'll be more than glad as usual try to get you one. I've been kind of slow at the gate here lately because of work, but I am still more than glad to help when I can. So thank y'all, and Have a good weekend. I'm going to have a good rest of mine.